I'd like to welcome everyone to the first OpendTect webinar. The subject of today is an overview of OpendTect's Common Driver plugin. My name is Jaap Glas. I'm a software developer at DGB Earth Sciences, and I'm the first responsible for the development of the Common Driver plugin. These are the contents of what I'm going to talk about today. First, I will give a short introduction of the plugin, what are the objectives of the plugin, and what are its main components. Next, I will give a demo of the command recorder. After recording a script, you cannot expect it always to run the way you want it, so some script editing has to be done after the recording, and I will talk about that. Then I will give a second demo on the common driver, and which will show how to execute the script we just edited. After that, I will show you the other language features of our script language, both the one which are currently available and the couple we want to implement in the near future. Then I will talk about some user experience, what are users already doing with the Common Driver plugin, and what do they like to do with it in the future. We will finish with questions, and I propose to postpone the questions till after my presentation, because it's very difficult for me to keep an eye on the questions at the same time as giving the presentation. What was the goal of this plugin? Well, we wanted to develop a user-understandable script language for OpendTect. It should not only be understandable for us programmers, but also for people from our case studies department. There are a couple of application areas where we can use such a script language. From a programmer's perspective, our first objective was to use it for automated testing. Automated testing is an indispensable element in agile software development. We programmers are not afraid to change whole pieces of old code in order to improve their functionality, but we need methods to verify whether the existing workflows keep on working. Another application area of the script language is workflow scripting. One can use the script language to specify a workflow very precisely and share it with other people. You can, for instance, specify a workflow and report it to us when you find a bug. Workflow scripting is also very useful to facilitate the user in doing repetitive tasks. If you have to do the same workflow over and over again, why not do it automatically? It will make life a lot easier. Finally, another application area would be OpendTect demo purposes. If I'm at an exhibition, I sometimes see two people presenting a demo, one of them telling the story, but the other one being very busy clicking lots of buttons to reproduce the demo. And if he could use scripts, his work would be at least easier, and he might even become redundant. What does our plugin look like? Well, it has a couple of main components. The first one is the common driver. The common driver executes a script. If you start it, you can enter the name of your command file, and you can also enter the name of another file, which is the log file, and if it happens that an error occurs, you can find in the log file what has happened. The second component is the comment recorder. Comment recorder can be used to record a script automatically. And the third component is a tooltip name guide. The tooltip name guide is a tool attached to your mouse pointer. If you switch it on, then if you move your mouse pointer over the graphical elements of the windows of OpendTect, a tooltip pops up with the name of the element on which your mouse cursor is currently located. And this is very useful because a number of graphical user interface elements you see in your screen do not have a visible title. So by using this, you can still find out what is their name to be used in a script. The access of the plugin is from OpendTect's main menu. If you go to Utilities, Tools, Common Driver, then you find in the current versions of OpendTect the submenu with the components listed in that submenu. In new versions of OpendTect, you will get a Common Driver control window instead of this. This is shown over here. This is a standalone window which can stay open all the time, and that has the advantage that other windows which pop up in OpendTect can never block your control window, so you can always start a script and stop a script, and start a recording or stop a recording. So now we'll go to the first demo of the command driver, actually the command recorder. This is OpendTect, you might know already. And I first show the tooltip device. So we go to Utilities, Tools, Common Driver. We select Tooltip Name Guide. And if I now move over elements in my window, then at every element it tells you the name. And for instance, such a thumb wheel doesn't have a name, you don't see anything, but by using this you can still find out what it is called. So let's now do the first step, which is recording a script. And we're going to record a small script which loads a horizon and adds some contour lines on it. So we go to Utilities, Tools, Common Driver, Start Recording. Then we get a window and we enter the name of the script we want to record. I call it webrec.command. And we say OK, and from now on everything will be recorded. So the first thing I do is I go to this button and I restore the home position. Then I go to the tree and I load a horizon. I get a window and I select the MS4 horizon and I click OK. It is loaded. I cannot see it very well. Yeah, it's okay. Now I want to put contour lines on it. So I'm going to go into the tree to find that. And oh, oops, I'm at the wrong window over here. It's not in there. I should have been in this one. Over here there is Add Contour Display. I click it. And I see contour lines. So you see them a bit better. And let's say I'm not very happy with the color and thickness, so I'm going to the Contours 3 item and I select Options. Over here I have a button for the line color. I click it and I say, well, I'd rather have them green. Click OK. And white, yeah, the white is also a bit thin, so let's increase that a couple of steps. And I say OK. Well, now I'm about ready with my recording, so I go to the menu again, Utilities, Tools, Common Driver, and say Stop Recording. Well, what you can do is, of course, you can immediately start to try and run the script you just recorded. So we go to Run, and we fill in the name of the script we just recorded. The log file is fine, and I click OK. You see that it starts doing things, and on where the cursor then shows a forbidden sign, and now it stopped without doing everything. So that's what you can always expect to happen, that the script you record does not fully run at once. You have to do some editing and some things to make it work better and make it more generally applicable, and that's what I'm going to show now. So I go back to the presentation. And over here we have the script we've just recorded, the horizon load script example. Every script that is recorded is having a number of paragraphs like this. Every paragraph starts with the name of the window in which the commands have to be executed. So in this case, between square brackets, OpendTect main window. Well, the first comment we did in our demo was we clicked on a button called To Home Position. And then after that we went to the tree menu, and the tree item was horizon, and the menu item we selected was load. Well, this made a new window pop up, which was the horizon selection window, and in that window we did a list click. The name of the list was called object list, and the element we clicked on was called demo MFS4, and it was a left mouse click. And after that we clicked on the button OK. Then we were back at the OpendTect main window, and we went to the tree and we clicked on the tree item horizon, sub item demo MFS4, Z values, and it was a right click. Well, that was our erroneous click when we wanted to add the contour display, but we were on the wrong menu item. That's what happens. The recorder does reproduces exactly what you do, even if you did not want to do that. So that was this comment, and then we did it right. So then we did a tree menu command. The tree item was called horizon, sub item was called demo MFS4, and we selected the add contour display item. After that, in the same window, we did a movement of the thumb wheel. The thumb wheel is called V-rotate, and we rotated it by 30 point something degrees. And after that we went to the tree again, popping up a menu called from the tree item horizon sub item demo MFS4 sub item contours, and we selected the options menu item. That made a new window pop up which was called contour display options, and over there we clicked on a button called line color. Then we ended up in a window which was called select color, and you if you remember it, we over there clicked on a button to select the green, and after that we clicked OK. This is a bit different, and that's because that color selection window is not a window from OpendTect. It's actually a window which is borrowed from the GUI toolkit we use called Qt. That also makes that we do not have access to the internals of that window. So the only thing we can do with such a window, we can close it and find out what the results are, and that's why over here in this paragraph there is not something like button green and then button OK, but there is a special command called color OK, which gives the final result of that window, which is in RGB values the green color. Well, after that window was closed, finally in the contour display options window, we did 3 clicks on the spin box, and that spin box was called width. What you can see here is that the comment recorder has some capabilities to summarize what you are doing. We clicked 3 times on the spin box, but it is that smart that it combines them into one command. After the spin box, we did the final button OK, and that made us finish the script. Well, you have recorded the script, but that's not enough to run a script normally. This is a recipe to generate a script which you can use more than just today, but maybe tomorrow as well, and maybe in a bit of a different situation as well. First, you record an initial script, like we did. Then you run the script to verify whether it reproduces. If it does not reproduce at all, or maybe only partially, you go to your log file and you see what are the errors in order to solve them. And you edit your script for a couple of reasons. That editing of that script can be done with a simple text editor on Windows, for instance, the Notepad or the WordPad, on Linux, VI, or whatever you want to use. And there are a couple of things you can edit in the script. First, you can remove the comment recorder anomalies, like for instance the click on the wrong menu item we did in our demo. But for instance, you sometimes are a bit impatient and you click twice on the same button fast after each other. Well, you can clean up your script by removing things like that. You can also make your script more general and robust. The comment recorder is very strict. It gives exactly the name you click on, and you might want to do it a bit different. Maybe it gives the name of a horizon, and actually you mean that it always has to do that first horizon in the list, doesn't matter what name it has. So then you change the script a bit to make that happen. You can also insert a number of auxiliary comments, for instance, to make the script run slower, because normally the script runs as fast as it can, but if you want to see what happens, you might stop at certain positions. So you can add a comment for that. You can also, for instance, add a comment to tell the command driver what it has to do in case it finds an error. Should it stop immediately? Should it try to go on? Things like that. A small look at the command log file. I selected a couple of relevant passages. This is how it looks like. It did an action at a certain time, and then it specifies what action it did. This is the right three click on the MFS4 Z values menu item in the tree, and it tells you I did it in this window, OpendTect main, and I found an error. And the error is I found 2 available tree nodes defined by path, horizon, demo, MFS4. And I cannot go on because I do not know which one to choose, and I fail. Well, this is what happened when we immediately did run our recorded script right after recording it, and what we actually did, we forgot to clean out tree, so that's why it stored the second horizon with the same name in the tree, and then when it had to do the next comment, it didn't know which one to take anymore. So after solving this and you run it again, you will find this message. Again, it did that same action, 3-click right. In this case, it does not give an error, but simply a warning. It says, unexpected pop-up menu clicked away. Item selection needs a menu variant of this comment. That is not an error, that's simply a warning, because actually it is a bit in doubt. Did you really mean a right click on the tree item, or did you actually want to select the menu item over there? It doesn't know for sure, so it tells you if you want to change this, do. Well, if I go back to this one again, of course this script generation recipe has to be kind of loop. You run the script, you look at the errors, you edit it, then you run it again to see whether it's already running, and after a couple of loops you are fine with it. I'll now show you how I edited the original horizon load script we just recorded, to give some examples of what you can do. It is not that everything which is in here you should do as well to make your script better. It's simply a couple of examples. The things I removed from the original script are grayed out, and the things which I added are displayed in green. So before starting the script, I added the comment sleep 1 regular. That means that instead of executing all comments as fast as possible, I say between every comment wait for 1 second, and then it is shown more like a movie. What else did I change? Well, you might already have seen that when I was running the demo, actually the items were not called demo 4, but demo 1 MFS4. So when we have different versions of our demo survey, sometimes the names are a bit different. That's of course very impractical if you want to run your script on several surveys. So we're going to make this horizon name a bit more general. The first thing we do is we remove this part and we add wildcards. These are those asterisk characters. If I add a wildcard in front of a search name, MFS4, it does postfix matching. If I add a wildcard at the end of a search name, it implements prefix matching. If I do it both at the beginning and the end, it is a matching of this MFS4 substring. Another thing we can add is this hash symbol with an index after it, and that's what we call the disambiguator. Let's say that this string to match results in multiple matches, then this disambiguator tells what match to take. So in the case that there were two same named horizons in the tree, then this one would say, okay, if there are two, take the first one. Well, over here we moved the anomaly from the comment recorder, because that was where we wrongly clicked in the tree, so we can simply remove that. This one is again the generalization of the MFS4 horizon name. Well, what I did over here, oh yeah, I was turning the thumb wheel. Well, to make it more nice, I'm not interested in the small numbers. I simply want to rotate it by 30 degrees, so I remove the rest. This one again is a generalization of that MFS4 search name. And then we come over here. Yeah, at second thought, I thought green was not a good idea. I simply want yellow contour lines. And well, there is an option at that color OK command which does not necessarily have to specify the RGB values, but it also knows a couple of names of colors, so I add yellow instead of the RGB values. Over here, oh yeah, with the spin box, at second instance I thought, yeah, maybe it's not smart to increase it by 3. I simply want it to be 4, and yeah, if it's originally not 1, maybe in another situation it's not, that's not smart. So instead of increasing the spin box with the arrow up and the arrow down, I fill in the input field of that same spin box, I fill in 4, and that makes that I have to use the input command instead of the spin command. A final thing, which is especially useful if you do automated testing, there is a snapshot command, and with the snapshot command you save a snapshot, a screen dump of the current situation of OpendTect, and in this case I send it to this file path. What you see over here is a placeholder that's between the dollar signs, and it's a predefined path, and that makes that you can specify survey independent file names. Well, this is more or less how I edited the script, and then now I want to demo this edited script with the command driver. So I will remove my tree now. Let's see. Remove. And I'm going to run the edited script. So I go to Utilities, Tools, Command Driver, Run. And I select the edited script, which I called WebRec1. Log file is fine. And I press OK. It starts running. It starts running more slowly, you can see, because of the sleep command. And I'm sitting with my hands in the air, and everything has been done automatically, although I cannot prove this, that it is the case. It really is. So the cursor is normal again, so it has finished its execution. And indeed, we can see that we now did run the edited script, because now we have yellow contour lines. Well, this is how the command driver works, and I'm going back to my presentation now. Now I'm going to give an overview of commands there are in our script language. You have already seen a couple of them, but there are many more. Many of those commands are accessing all the different GUI elements you can find in the windows of OpendTect. Before we had the command recorder, I now would need to explain you all of them with all the syntax and things like that. Now we have a command driver. I can advise you simply to make a recorded file and see in the file what effect has your action on a certain GUI element, and what effect does that have in the recorded file, and you can see what command is used for it. And if you are not really satisfactory at that moment, you can still go to the syntax in the manual to see what you can do to change it a bit. But I do not have to explain each of them. Except for these category of commands, there are also a couple of others I want to mention shortly. There is an include command. Like in programming languages, you can include one command script into another. There is a case command with the option sensitive or insensitive, which tells how to do the matching of the search names. There is an on-error command which specifies what to do in case of an error. You can say stop immediately. You can say continue with the next command and let's hope for the best. And there is one special option, which is the recover option. The recover option can be very useful in certain circumstances. I will give an example. Let's say that you record a script, and in that script at a certain moment you save something to a file. If the command driver would later on run that script, probably an extra window pops up which says, yeah, I already have that file, do you want to overwrite it? That is not included in the script you recorded before. And if you use the command driver with the recover option, then it is that smart that it can see, okay, this is a window which is not expected, let's click it away and try to go on after removing it. And that works very well. There is the sleep command, which can have the option either regular or extra. If you use extra, then it only stops between the two commands where you put the sleep, and after that it goes on in the normal speed. Except for the color OK command you already saw in the example, there is also a file OK, because also the file selection window is not an OpendTect window, but is also borrowed from Qt, so it needs a special command. We've also already seen the snapshot command, which has the options either to make a snapshot of the current window, OD main window, or even the whole desktop. Some other language features apart from the commands. Well, we've seen the wildcard operator to do either prefix, postfix, or substring matching of all the search names. And you have to use the asterisk character for that. We've seen the disambiguator, which is the hash symbol with an index after it, which is used to solve ambiguous matches. And that index, if normally counts positive and then takes the first or the second or the third match, but if you use negative numbers, then it counts from backwards. So then, by for instance saying hash -1 would mean take the last match. We have seen directory placeholders between the $signs, which are used to create survey-independent file paths. And one other feature is that the file paths which are recorded are platform adaptive. So if you record a script on Windows and later on it is run on Linux, then the backslashes are automatically replaced by slashes. I have to say something about the compatibility of the script language. There are two types of compatibility. Forward compatibility, which would mean that, let's say, OpenTect 4.1 can run scripts that are made in OpenTect 4.1. And there is backward compatibility, which means that OpenTect 4.1 can run scripts that are made on OpenTect 4.0. Forward compatibility is very limited. If, let's say, there is a change between 4.1 and 4.0 in the layout of the graphical user interface, or in the order of menu items or list items, or in the size of a menu or the size of a list, that's can be guaranteed to be forward compatible, but that's about all. All the changes are not. All the changes are backward compatible if it is a change in the command syntax. So if we make a new version of OpenTect and of the command driver with new commands, the old commands will still be supported. What is not compatible, that is, for instance, the naming of graphical user interface elements. If, for example, I have the name of a menu item in OpenTect 4.0, and for whatever reason we decide that it is not a good name and it has to be changed in OpenTect 4.1, then your script will not run anymore and you have to adapt it yourself. The same with a design change of the graphical user interface. If we have a window and at a certain moment we decide that it is necessary to split it in a window with a sub-window, no way the common driver will be able to cope with changes like this. So also then you have to change your old script or maybe record it again, which is sometimes even the best option. Well, this looks very bad, but it's not that bad because existing workflows, their naming and designs doesn't change that much anymore. So we cannot guarantee that compatibility, but in lots of cases your script will still run in the next version of OpendTect. But the only message is that you always have to be alert that it might not run and that you need to change something. Well, what are our development plans for the near future? We want to add a couple of things to our language. One of them is parameterized scripting. The idea is that you go to the command file and you replace one or more expressions by a kind of placeholder. And when you then start running the script, a user dialog will pop up which allows the user to specify the actual content of the placeholder. And by that you can make a script which is much more generally applicable and can be used in many different situations. For instance, you parameterize the name of your horizon, and at the beginning of your horizon load script you fill in the name of the horizon you want to load, something like that. Another category of comments to add are the control flow comments. We would really like to have some kind of conditional comments like we know from programming languages like the if, the for, or the while comments. If we implement that, we also need variables and assignment of these variables and some operators, some logical operators, some arithmetical operators, and probably also some predicates. For instance, a predicate to ask the size of a list, or maybe a predicate to ask whether a certain button is on or off, or maybe a predicate which asks whether a certain file name already exists or not, things like that. A third category are the scene interaction comments. If you now record the script and you do an action in the scene, you click with your mouse to put a seat somewhere, or you drag something to move an inline or a cross line, that is not recorded, and there are also no comments by which you can specify it yourself. That is simply something which still has to be added to the common driver. Well, some examples of external interest in our common driver already. A.G. Curran from Mac Energy asked at a certain moment, I want to write a script to load all my wells and horizons to make an automatic movie. Well, that is already possible, only with the control flow comments like a for statement I was telling in the previous sheet. It would make his life even a lot more easy. The next one, Alexander Shabasov from SOCAR asked whether it is possible to import 200 to 300 wells at once, since it will cause the work to be faster. Yes, this is possible. Of course, it would be very good if the import parameters are the same for all 200 to 300 wells. But in that case, it is possible. But again, if you would have a for statement or a while statement, you would be able to implement this a lot easier than you have to do it now. The third question, can this plugin be used to produce some kind of workflow tutorials? This was from BG via my colleague Arno. Yes, that's possible with some limitations. You might have seen this in the demo as well. If the common driver is running, it doesn't show any movement of the cursor. And it also does not show when a menu pops up. So that might make it very difficult to use this at the tutorial at the moment, because you do not really see every step that is happening. Well, I want to tell very shortly what my own colleagues from the case studies department already use as a workaround to do repetitive tasks. First, they record a one-task OpendTect script. Let's say, for instance, they load one horizon with the script. Then they generate an n-task OpendTect script from that one-task script. They use a text editor like a WordPad, a VI, whatever. Or even better, they use a general purpose script language like C Shell, Awk, or Perl to generate that one task OpendTect script from the n task script from the one task. And they concatenate the one task script n times, and then they start replacing relevant text strings. To give an example, with the horizon loading, you can, in the consecutive horizon loading parts, you can at every time change the horizon name with something else, and if you would change it with a wildcard combined with a hash symbol, the disambiguator, with an index number, and in every next part you would increase this index, then it would step by step load all horizons. If you have generated the n-task OpendTect script, you can run the n-task script with the command driver. This, of course, will be easier if you have for statements, while statements, if statements, like that. But at this time, this workaround still helps my colleagues already to do useful work with it. Well, for more information, complete information, you can find in the user documentation, Appendix B. There are even much more than what I told over here. And there is also a table with the syntax of all the commands that are currently available. And for almost any question on the command driver, any support, I advise you to send me an email, because I either can solve it or I know the person who can.